Dear, absorption is a process when you take something in, you get excited, you come back. When your friend tickles you, what happens is they take their finger on your waist, you get excited. You stay there for a long time. No, for a very short time, you come back. So that's what the entire idea of excitation is. So what is the concept of excitation? What is ionization? Let's understand. Okay, what excitation is really, let us understand with the help of this beautiful video in front of you. So in the entire process, the fleet of photons are coming in the entire pair, and all these nucleus and electron, they are just wobbling like a saturated atom, a beautiful atom. So what happens is, when the electron absorbs a photon, it gets excited. It stays there for a very less time, and after staying for less time, what happens is it comes back, photon is given out. So that is what excitation really is. Beautiful idea. Now we have seen what excitation really means. But what about the ionization? So the idea of ionization can be explained with this awesome video, and let's have a look of what happens to our electron. Ionization. So let's talk about the type of orbits. Dear students, what I can see is a beautiful atom. Okay, now there is a nucleus, there is this first orbit. Okay, so first orbit is the one which is closer to the nucleus, n equal to 1. The radius is r1. Then we have a look at the second orbit, okay, n equal to 2, whose radius is r2. Then we have another orbit that's called third orbit, that's called n3, and whose radius is r3. Now, electron was simply revolving in a very lowest energy state called as ground state. So if you say n equal to 1, automatically it means ground state. Now when you supply photon to the electron, it gets excited if it goes to the second orbit. But for electron, it was first excitation. So that second orbit is called first excited state. Now if you supply more energy, instead of second orbit, it jumps to third orbit. So it's not the first excitation, it's the second excitation. That's why third orbit is called as second excited state. So what will be sixth excited state? It will be fifth orbit. Wrong. It will be fourth orbit. Wrong. First excited state is second orbit, so fifth excited state is sixth orbit, not the fourth orbit. So, what is excitation energy? The idea is very simple. Now see what happens. When the photon comes, strikes the electron gets excited. Okay, so when the electron gets excited, it's called excitation. The minimum energy required, okay, the lower energy to higher energy is called as the excitation energy. So if you ask me, sir, what exactly excitation energy is? It is nothing but final excitation energy minus initial excitation. Such a simple. Both third postulates. So n equal to 2, so first excitation n equal to 3, second excitation n equal to 4, third, so on and so forth. What is potential? We understood energy, but what is potential? Potential is the amount of voltage which is applied to get it excited. So what is basic potential formula? It is energy upon small e. See, W is equal to QV. Work is Q into V. Work is energy. Okay, Q is E. So capital E is equal to E into V. So what is V is equal to? Capital E upon small e. Okay, so that is the whole idea of excitation. What is ionization? Now you supply the photon in such a way that electron goes out of the atom. Atom becomes ion. It's called ionization. So for that, the ionization energy is nothing but E infinity minus E of ground state. And we have studied this before also, King's formula. Ionization is equal but opposite to total. So what is ionization potential? Same energy upon charge. Simple idea of excitation and absorption. Now, let us come towards okay, fine, these are certain values of hydrogen, helium, lithium. Why? Because energy is proportional to Z square. If you want to understand, you can understand, because it is not there in your government textbook. Proceeding forward, the relation between small n and capital N. What is small n, beta? It's called the orbit number. Capital N, it is the number of spectral lines. So as you can see, if there is first orbit, there is no excitation. There is no emission also. How will you jump there and there itself? No. So the number of spectral lines is 0. If you have two orbits, let's say if n equal to 2, so I can make one jump from 2 to 1. Wow. So I will have one line. If let's say n equal to 3, I have 3 lines, nice lines, 3. So I will get emission from 3 to 2, 3 to 1 and 2 to 1. So can I see 3 lines? So for 3 orbits I have 3 lines. For 4 orbits again, let's see. I will have the transition from 4 to 1, 4 to 2, 4 to 3. Adding up, so I have 3 more lines, that is 6. And if I have 5 orbits, so what will happen is from 5 to 1, 5 to 2, 5 to 3, 5 to 4. More 4 lines. So 6 plus 4 is equal to 10. So what is the relation? The relation is very simple. Capital N is equal to small n into n minus 1 upon 2. Here we complete with the idea of absorption and the number of spectral lines. See you soon with the next module. Bye.